Hello everyone. Um, in the coming videos, I would like to show the manipulation of the modeling of MTT FEA models. Today is the video 1. In this video, I would like to show the manipulation of a sketch. In this video, we need to familiarize with ABAX environment and familiarize with the part module. And in this video, we're going to sketch the pinion components, including the rim, teeth, web, and shaft. Now let's get started. So that's the ABAX operation environment, and that's the tree, that's the module, and that's the chew. So basically, here we go. We create a model. We call it MTT. And in the parts tree, we create one. We name it as okay, it's a 2D planner and deformable. We call it the pinion. So basically, the first part is about the rim and the teeth of the gear. Okay, and the base feature is a shell, so we can choose the approximate size at 500. So that's our sketch paper. So you can there are several tools to plot. First, we need to create several construction lines, including the section in construction circle. So basically, we use that input to input the center and the diameter of the tip. Actually, first the construction circle is the tip circle, and the base and second one is a dim, and the third one is the third one is about the base circle. And now we can create construction lines. The first one is vertical, which also act as the interaction. And the second construction line is about the boundary of the teeth. Okay, that's it. I strongly recommend you use the input as the value instead of catching up the points. Okay, we can also use the dimension to measure whether the construction line is okay. Okay, we're gonna to plot those our teeth in that region. So we use the spline line to create a evolute line of the teeth. So we just input the coordinate one by one node by one node. I just speed them up. Okay, I create five points along the evolute here. So we create evolute here, and we use a circle to create the external face of the gear teeth. So select that one and use that one, or input the value as from. There we go. Okay. And for the fillet, there are several ways to create the fillet from the evolute line to the base circle. Currently, I'm using tangential ways to introduce the fillet. So first I plot the baseline circle, the arc, for a certain distance. Finally, we will trim it, so don't worry about the length now. And now we create a tangential circle arc from there to there with an arbitrary radius, and we can use the dimension to impose the radius. Currently I set it 2, but you can change it. And we select the other one, just link them as a line, but we currently use the tangential constraint to make it tangential. Okay, so but it's a bit changing now. Okay, so basically the fillet is generally finished. You could use different ways to create the fillet. Now we have half of the teeth face, and now we need to use the mirror. Hold it and select mirror, and first we'll select the mirror place. symmetrical line, and select the mirror entities. Select all of the lines. Use Shift. Yep. Select all of the lines we create. So click OK. So there we go. We create one teeth now. Next task, we need to use the radio pattern to copy all of the lines. Here we select all of them. Okay. Yeah. Be careful. Select done. Okay. So originally we have 31 teeth along the whole circle, but actually we just modeled 1/4 of them. So basically we modify that at 8 teeth, and the total rotation angle is gonna be that one. Because it's clockwise, so we can minus. We can select the center of the rotation. We can use 0, 0 as input, and we can preview it. It's fine, generally it's fine. We can check the details. There might be some mismatch, but we will deal with them eventually. So basically, next task we need to close it to finish the rim. Use the lines. I can connect the nodes together, and finally we will trim them. Don't worry. Yep, and use trim, auto trim. It's very smart. Yep, select each bit. Okay, we can examine them whether they're okay. Yeah, roughly they are fine, and we can erase all of the construction lines and circles to make it clear. Okay, and we can remove all of the gaps and overlaps. Let's see what's going on. We can select most of the teeth, or select all of them. Okay, and select tolerance 0.01, let's say, and let's see what's going on. Okay. Now there is a warning. We cannot create the part properly because there are some overlap. For example, here, and some intersects at the at there. So basically, we need to make them coincide together, make all of the overlap together exactly. So we use the constraint as well, and remove all of the gaps and the overlaps. Yeah. Now this should be fine. Let's see what's going on. Okay. Ooh, that's it. That's the rim and teeth. And next one. Okay. So we finished the first task, rim and teeth. Next one will be the web. So create a new one similarly. We name it as pinion web. Okay, it's still 2D deformable, and the shell, the promise size is same, 500 something. And similarly, we create construction lines and circles firstly. Yeah. Vertical one. And the inclined one. Same angle here. Create the horizontal one. And create construction circles. So that's the external radius, inner radius, and is the outer radius. Okay, that's a rough sketch, so we can create solid lines within this sketch. We need to create another construction lines with that angle. It's half of the range. So basically create that one, also passing through the central line, central point. Create arc, the external circle. Yeah, select the radius and select the end of. Don't worry if you have problems, we can trim it finally. That's one inner as well, inner arc, and we can close them by connecting the end points. Okay, roughly okay. So let's see. Okay, let's see. Okay, we got the web, and now we're gonna to model the shaft, sketch the shaft. So create, but this time it's a bit different because we believe the shaft external surface is as analytical rigid. It's a wire one, so but other stuff is similar, and we can rename it afterwards. Don't worry. And we select a circle. We need the construction lines as well, but this time we need to create a longer arc, basically which is able to transfer all of the torques from the shaft to the gear. We select relatively large range of the angle. For example, we select 30 degree. Oh no, maybe it's minus. Okay, it should be minus. Okay, there we go. Select that one. Select the central point. Okay, that's construction lines, and we can create the curve. Actually, the arc. Select radius. It's 30 for my instance. Okay, that's a whole circle. We need to trim it. Don't forget, use the auto trim. It's very smart and helpful. Trim the section, the arc one by one to achieve the desired shape. Oops. That's it. Okay, that's how we can trim more, but generally the shaft is finished. We can rename it as pinion shaft. So that's all of the model. I can add a reference point to the shaft to apply the rotation and torque. So that's all of the parts. So basically we finished the rim, web, and shaft, and that's the summary of this video. This video shows operation on the sketching of the geometry of the pinion components. We should be able to sketch the pinion as well as the wheel according to the preceding calculation of gear geometry. We'll be able to assemble the parts together, define the material property, and apply load and boundary conditions in video 2. Thanks for watching. See you in the next video.